Well, hello students, this is Mr. Laws. I hope you all had a nice break. My wife and I had an opportunity to go to Europe, and the way things worked out, it's going to take a couple of extra days to get back to South Jordan. In the meantime, I've asked a good friend of mine to do me a personal favor and substitute while I'm gone. She is very good at math, and I expect you to treat her with your very best behavior. I will feel personally insulted if you don't behave. Besides, I have given her permission to take names of anyone who gives her any trouble at all, and I will call their parents when I get back. So please show her how good Elkridge students can be, and as a favor to me, do your very best. Thanks. Well, let's take a look at the topic that we've got today. The I can statement for this section is I can perform operations using scientific notation. So we're going to write the word notation right here. And as a warm-up, as a starter for this, we're going to review a couple of the skills that we have for working with exponents, but we're going to change things up just a little bit. So this says simplify the following and write all exponents in the numerator. So it says we've got to write them in the numerator, even if they need to be negative in order to make that happen. So let's take a look at this one right here. We don't have any negative exponents on this one. Everything's already in the numerator, so we're going to take care of the numbers, find out what the final coefficient is here. 5 times 6, that's going to be 30. And then I have a to the second times a to the seventh. Same base, so the base is going to stay the same, and then we add the exponents, so we get 30 a to the ninth. We're going to circle that. That's our final answer on that one. And then let's take a look at this one. Here we have some negative exponents. So normally we might do something like this. We're going to multiply the 10 and the 2 together. We're going to get a 20. We don't like the fact that that's negative, so remember negative in the exponent means reciprocal, so we're going to put a b to the first down in the denominator. Same thing with that b to the fourth. We're going to put that down there. That's going to give us 20 over b to the fifth, and we would normally leave it like that, but we're going to see that there are times where having the exponent be negative is actually a useful thing. In a couple of particular cases, we're going to cover one of those today. So we could do one thing here. We could take this and move it from the bottom to the top. That would be 20b to the negative 5. If it's in the denominator and it's positive, if we move it up in the numerator with the 20, that's going to change the sign of the exponent, and it's going to give us this. Or we could look at it a different way. So I'm going to zoom in on this one and take a closer look. So one way that we could do this is just use our normal rules for exponents and say, okay, we're going to multiply the 10 and the 2 together. That's going to be 20. And then we would add the exponents together. So this one is a negative 1, and then we're going to add a negative 4. So this is going to end up being 20, and then negative 1 plus a negative 4, that's just going to be negative 1 minus 4, so that's going to be b to the negative 5. So either way, whether we do it this approach, which takes a little bit longer, or this approach where we're just applying the rules for exponents, that's going to be just fine right there. We're still going to get b to the negative 5. And again, we don't often write things with negative exponents, but we are going to here, and you'll see why in just a few minutes. So let's take a look at this one. We've got a 20 and a 10. We're going to go ahead and divide those. We end up with 2 once we've reduced that. And then I'm going to use those rules for exponents. You'll see that we've got this upper exponent right here. We're going to take the exponent on the top and we're going to subtract the exponent on the bottom. So we're going to subtract negative 7. So that's going to give us, let's see, minus minus, that's going to be a plus. That's going to be that's going to be a to the negative 5. And we can just leave the answer like that. If I wanted to, we could go about this another way, kind of like we were doing over here. Let's reduce the numbers. That's going to give us a 2 on the top. And then we don't like this being negative, so we're going to move that one to the denominator. So we're going to have 8 to the 12th down there. And then again, negative means reciprocal, so I'm going to move that one from the bottom to the top. We can change the sign of an exponent by moving it from top to bottom or bottom to the top. So we have 8 to the 7th. So then I'm going to do the same thing we had here. We're going to cancel these 7 with 7 of those. That means there's going to be 5 left. So we have 2 over a to the 5th. And then again, this says we need to write everything in the numerator. So let's go ahead and move that up in the numerator with this. So we're going to have a 2 and then a to the negative 5. So regardless of which way you do it, we're still going to get the same answer there. And again, we're going to talk about why that's important in just a few minutes. So let's take a look at the next one. I'm going to go ahead and take care of the division here. So when we cancel the 2 with the 8, 2 goes in here once, 2 goes in here 4 times, so we've got a 4 in the denominator. We don't like that being negative, so I'm going to move it from the bottom up to the top. So that's going to be x to the 4th and another x to the 4th. So we end up with, altogether, this is going to be x to the 8th over 4. That's one way we could write it. Another way that we could write it is we could actually pull that 1/4 out front and then write x to the 8th. This is probably the best way to write it for right now. If we got really fancy, if we wanted to, we could, I suppose, write that as a decimal. We could do 0.25 times x to the 8th. And any one of these would be okay. Since the original problem was written with whole numbers in kind of a fraction form, these two right here would probably be the best ones. So the reason that we want to kind of look at exercises like that is because of scientific notation. And let's recall the rules for writing numbers in scientific notation, and then we're going to learn to perform some operations. So the first rule for scientific notation is numbers must be written in the form, and we wrote it like this. We wrote an m, and then we used an x to represent multiplication, and then 10 raised to some power, raised to the power of n. So we've got to have a decimal number right here, and then times 10 to some power. So remember that that number in front, that decimal number, okay, it's got to be a decimal number, and it can only have one non-zero digit in front of the decimal. And if you've practiced section 12.7, if you've worked with scientific notation a little bit, you remember how that works. We are going to do a couple of those here in just a second, but I do want to remind you that when we perform operations with scientific notation, we're going to use the typical rules that we've worked with any other exponential expression. So the product rule for exponents, in other words, we add the exponents when we're multiplying the bases, same base together. Quotient rule is that we subtract exponents as long as the bases are the same, and that the answers always need to be in scientific notation when we're done with these. So we're going to do some operations with scientific notation. We're going to use these rules right here, the product rule for exponents and the quotient rule for exponents. And then we just want to make sure that the answer is always written in scientific notation. So what it comes down to is you can almost treat each problem below, these problems down here that we're going to see in just a few minutes, as two separate problems. The first thing we're going to do is we're going to perform the operation on the decimal numbers. So we're going to use our calculator to help us with these for the most part. And the second part is perform the operation on the powers of 10. Remember, scientific notation is always using powers of 10. So we're going to perform the operation on the decimal numbers, we're going to perform the operation of the powers of 10, and then we're going to make sure that the exponent is written on the top, okay, up in the numerator if you want to think of it that way, even if that means having a negative exponent. So you'll remember in the last section we saw several problems where the answer actually had a negative exponent, 10 to the negative 5, 10 to the negative 3, whatever it happened to be. In fact, I think we saw some really big exponents as well, like negative 19 and stuff like that. Okay, and then when you're done, we just want to make sure that our final answer is written in scientific notation. Okay, so kind of restating here. But it's probably easier just to take a look at some of these problems and see how they work. So let me show you what we've got here. We have 3.5 times 10 to the 7th times 4 times 10 to the 5th. So here's what we're going to do. We're going to take care of the decimal numbers first. So grab your calculator. I'm going to go ahead and grab my calculator. I'm going to slide it over here so I can do a couple calculations with it, clear a few things off here. So I'm going to do 3.5 times 4. So we'll type that into the calculator. We'll see what that gives us. That gives us 14. Now if that's something that you can do in your head and get it right every time, that's totally okay. So I'm going to write the 14 right here, and then I'm going to write the x for the times, and make sure that that looks like an x so we don't confuse it with anything else. And then we're going to look at these numbers right here. Well, then we have 10 to the 7th times 10 to the 5th. Well, what we would do here is we would, since the bases are the same, we're going to add the exponents. So this is 10 to the, let's see, 7 plus 5. That's going to be to the 12th. So we've taken care of the first operation of multiplying the numbers together, the decimal numbers together, we get 14. The second thing was we multiplied the powers of 10 together, so we get 10 to the 12th. Now we want to make sure that the final answer is written in scientific notation, and you'll notice that we've got an issue right here. So I'm going to change colors. Right now the decimal is right there. It's 14.0 if you want to think of it that way. Now there are a couple different ways that we can kind of figure out a way to remember how to do these, but this is the way I like to do it. We're going to take this number 14, and right now it has two numbers and two non-zero digits in front of the decimal. So we're going to go like this. We're going to move it over one place. So we're going to write the final answer as 1.4, and then think of it this way. We made the 14 into a 1.4, so we made this smaller. So what we need to do to compensate for that is we need to make this one bigger by one decimal place. So we're going to add 1 to that. So this is going to be times 10 to the 13. We made that one bigger. So if we have to move the decimal over here to make this smaller, we're going to compensate for that by making this one bigger. If you wanted to get technical about it, what we did here is we divided by 10, and over here we multiplied by another 10. Divide by 10 to move the decimal over, and to compensate we times that by another 10. So this right here would be the answer. So if you kind of keep that in mind, that we're going to be doing basically 2 problems and then checking to make sure that the answer is in scientific notation, that's what we're going to be doing here. So I'm going to zoom into this, get that calculator ready because we're going to use that again in just a second. So let's take a look here. We've got the 2.7 times the 5.2. So let's grab a calculator and let's figure out what that is. So 2.7 times 5.2. We end up with 14.04. So I'm going to write 14.04 here. And then let's take care of the decimals here. We've got 10 to the negative 7 and 10 to the 9th. We're going to add those together. So that's going to be 10 to the 2nd. Now again, we run into the same type of thing here. This is not in scientific notation. We're pretty close, but not quite. We need only one digit in front of the decimal place. So I'm going to take this and I'm going to move this over one decimal place. So we're going to make this 1.404. So again, you'll notice that we went from 14.04 to 1.404. So we made this smaller. So we're going to compensate by making this bigger. We're going to make that one bigger. So this is going to be 10 to the, we take the exponent that used to be 2 and we'll add 1. So it's going to be to the 3rd power. And that right there is our answer. So hopefully you're kind of getting the hang of this. We're going to take a look at a couple that involve division, maybe some bigger numbers and stuff like that, but let's go ahead and take a look at this. This may be something that you can do in your head, 2.4 divided by 1.2. Just for the heck of it, let's double check and make sure. So we've got 2.4 divided by 1.2, whoops, divided by 1.2. So that's a 2. So that means the decimal part of the number is 2, and then we're going to times that by, and remember, we're going to subtract the bottom exponent from the top. So this is going to be a minus 4. So that becomes a plus 4. So 7 plus 4 is 11. You can think of it that way, or another way to do this would be to say, hey, we don't want that in the denominator with a negative. Let's change the sign by moving it into the numerator. So that's going to be to the 4th power there, and then you can see that when we add those together we get to the 11th power. Now let's check and see. Do we have a decimal number with just one non-zero digit in front? The answer to that is yes. If you kind of wanted to make it perfectly clear, we'd do 2.0 and then times the power of 10. So that right there is the answer. All set and done. So not too bad. So take a look at those. I'm hoping that's kind of sinking in as to how we do these. We're going to do another division problem and then some other ones right here. Let's take a look at this next one. This one is a little bit different. We've got 7 divided by 10. Now you may know what that is, but remember we have to make a decimal out of that. That's 7/10. So hope you know what that is. Let's just double check and make sure, confirm what you're thinking in your head that it is. It is 0.7. So 7 divided by 10 is 0.7. And then times, let's see, we've got 8 tens on the top, 2 on the bottom, so these are going to cancel with those. There's 6 left, so this would be 10 to the 6th. And then we've got a different problem than we had up above. This now is too small. Technically the number that's in front there is a 0. So what we need to do now is we need to make this one a little bit bigger. So I'm going to move that over one decimal place. So I'm going to write 7.0. So we went from 0.7 to 7. So what we did is we made this one bigger. If we made that one bigger, then we've got to compensate by making this one smaller. If we made this one decimal place bigger, we need to make that one digit smaller. So we're going to subtract 1 from that. So this is going to be times 10 to the 5th right there. And again, to make this bigger, what we did is we timesed by 10. And here we technically divided by 10. That's why the negative exponent there. But that right there is the answer. And again, that 7.0 kind of emphasizes that we know that that answer is in scientific notation. So let's take a look at another one. Let's look at this one right here. Get some fairly big numbers. Let's see what we get here. Let's do the 3.15. So I'm going to clear off my calculator. 3.15 times 6.2. Let's see what we get here. We get 19.53. So 19.53. That takes care of the decimal part. And then let's take the two of these. They both have negative exponents, so we're going to combine those. We're going to put those all together. That's going to be negative 14 altogether. And then let's take a look here. Again, we've got this issue that we've got too big a decimal number here. So we're going to move this over one place. So notice that this is going from 19 to 1.953. So we made this smaller. That means we need to make this bigger. Now I'm going to give you a second to think about how we're going to make this bigger, because what a lot of people do is they look at that and they think, oh, I'm going to make that bigger. That's got to be negative 15. Well, let's stop and think for a second. If we make that bigger, what we're doing is we're adding 1 to that. So we made this one smaller. We've got to make this one bigger. If we add 1 to that, that's actually 10 to the negative 13th. Negative 14 plus 1 is negative 13, and there we go. Okay. All right, let's take a look at this one right here. We're going to go ahead and do the division. And again, it's probably best to rely on a calculator to make sure that you get the answer right. If you want to take a guess, it is 0.25. Okay, so it is 1/4, 0.25, and then times 10. Let's check and see what we get here. We're taking 10 to the negative 6, dividing it by 10 to the 5th. We're going to subtract the bottom exponent from the top, so that would be minus 5. So we've got 10 to the negative, that would be negative 11 altogether. And then again we run into this issue right here. We need to make this one, let's see, we need one non-zero digit in front of the decimal. We're going to move this over one place. So this is going to be 2.5, and I'm going to give you a second to stop and think about that. So we've got 0.25, we made it 2.5. So we made this bigger. That means we need to make this smaller. Moved it one place, we're going to make it 1 unit smaller, so we're going to subtract 1. And that actually makes this, if you take a look there, negative 11 minus 1 would be negative 12. And there we go. So there's the answer to that one. I'm going to zoom out here and we're going to kind of take a look at these. I do want to spend just a minute talking about how we can tell which one's the biggest and which one's the smallest. We're not going to look at every one of these together, but what we're going to look at is just these three, just the answers on D, E, and F. And the question here is which number is the smallest. Now, you'll remember that scientific notation is used to represent really big numbers and really small numbers. And positive exponents are used to represent big numbers. So any of these with positive exponents, those are pretty big. And any of them with negative exponents, they're pretty small. And the bigger the negative number, if you want to think of it that, the smaller it is. So if you've got a choice between 7 times 10 to the 5th, it's not really this number that we're worried about. We're not really worried about the decimal number in the front. What we're worried about is that exponent that indicates how big or how small it is, because that's positive. That one's pretty big. This is 10 to the negative 13th. Okay, so think about that. That's moving the decimal over a whole bunch of places to the left, making a teeny tiny decimal number. Same thing with this one. But the larger the negative exponent, the smaller it is. So the answer to this one is 1.953 times 10 to the negative 13. That one's the smallest because it's got the biggest negative exponent. And of these three, the only one that's positive is this one right here, so that's going to be the biggest one. So 7.0 times 10 to the fifth, that one's the biggest. Okay, now many times people say, well, hey, can't these be done on a calculator? And the answer to that is yes, but you're not going to be able to use your calculator to do these problems on a test. You can use your calculator to do little calculations like this, but you need to be able to show that you can actually do these calculations by hand. So the answer there is yes, but you've got to be able to show your work and show how these work. So now we're going to take a look at problem number 20 on your assignment. I'm going to give you just a second to get that worksheet out. It's 12.8a. I'm going to flip over to that one, and we've done 6 examples that are very similar to ones on your assignment. And now I'd like to take a look at number 20. So here's the front side of the assignment. You'll notice as I kind of scroll through here, those should look pretty familiar. And I'm going to get over on the other side. Should still look pretty familiar. We've got a bunch of division problems right here. And then there's something different about problem number 20. So I'm going to zoom in and we're going to take a look at problem number 20. You're welcome to follow along and do this one together. So you'll notice that we have one number in scientific notation in the numerator and 2 that are being multiplied together down here. We've got this fraction bar here that generally breaks things into a top and the bottom, and so what we're going to do is we're going to simplify the denominator. So here's what we're going to do. I'm just going to rewrite this one here, 6.48 times 10 to the fifth. Make that look right. And then let's go ahead and multiply these together. So using the same skills that we were talking about just a second ago, I'm going to do 2.4 times 1.8. If we do 2.4 times 1.8, we get 4.32. So the decimal part of this number on the bottom is 4.32. And then let's figure out what the exponent is on 10. We've got raised to the fourth here and raised to the negative 2 here. So we're going to add the two of those together. So 4 plus negative 2, or just plain old 4 minus 2. This is a 2 right here. And once we get it to this point, then you'll notice that it's the same as all of the other ones on this page. We've got a scientific notation number on the top, and we've got a scientific notation number on the bottom, and now we're just going to simplify this just a little bit. So I've zoomed out here so we can kind of see by comparison what goes on here. So let's go ahead and take care of the decimal number, 6.48 divided by 4.32. We end up with 1.5. You might want to think ahead and think about what's nice about the number 1.5. And then what we've got is we've got 5 tens on the top and 2 on the bottom. So let's subtract that bottom exponent from the top, and we're going to end up with 10 to the third. Okay, now we need to look at this and think, is this in scientific notation? Do we have a decimal number with a non-zero digit, just one of them in front of the decimal? The answer to that is yes. And do we have this multiplied by a power of 10? The answer to that is yes. So that right there is the answer to number 20. So you're going to have the rest of the time to work on this. And good luck. If you need to, go back and look at your notes, refer to them. I think I've done one of almost every single type of problem that you'll encounter in the assignment. All right, thank you very much.